Hello, welcome to the presentation of some new products from ETI program. Today we will talk about the protection of battery systems. So, fuse links for the protection of battery and stationary battery systems. Content of the presentation. We will speak about general requirements about overcurrent protection of battery energy storage systems and power conversion equipment. Then we will say a few words about new standard IEC 6269-7, and we will look on ETI product range of protective devices for battery storage systems. On the market exist a lot of guidelines for installers. This is one example from Clean Energy Council, and then also guide for the protection of stationary battery systems. In such guides, there is a lot of useful information. What are the proper procedures for battery storage systems protection, and there is some rules what overcurrent protection shall. One of most important is that overcurrent protection shall be DC rated. Then shall be non-polarized. Rated voltage of this system and rated current should be defined under normal and fault conditions. Overcurrent protection should be rated to protect battery system cabling, so connection cables should also be protected. Meet relevant product standards. I mentioned some rules in the beginning, but up to 2 years ago, there was no proper standard for overcurrent protection. And that's why overcurrent protection shall be selected from the following product groups. One is definitely higher C fuses, higher rupturing current fuses. Second one are circuit breakers, powerful circuit MCCBs. And the most important is that battery system should have overcurrent protection installed in all live conductors. It is very important, and we should not forget this. There is some information in case of high rupturing current fuses selection. Usually, current limiting fuses are designed for DC and AC voltages, but usually AC ratings cannot be directly converted into DC rating. What does it mean? It means that AC voltage of one fuse is not comparable with DC voltage of the same fuse. DC voltage is usually lower than AC voltage. Regarding currents, the DC rated current is usually identical to AC current of the same fuse. So there is no changes. Regarding DC breaking capacity, there is always question from the customers, from the market. DC breaking capacity is not constant value, but it should be always considered in conjunction with the time constant of the circuit. So, higher is time constant, lower is the breaking capacity. There is an example from everyday practice. You can see circuit diagram of power circuit converter connected with batteries, 30 batteries in serial connection, protected by fuse, correct in plus and minus, but fuse were selected wrong by wrong procedure, and usual consequences could be visible here on these pictures on the right side. Fuse which is not designed correctly usually explode or has some other wrong operation procedure. So because of a lot of question from the market, we decided to develop new standard for battery protection fuses, and this is standard IEC 6269-7. ETI participate in the work of IEC Technical Committee 32. It is Technical Committee for fuses, and 32B is subcommittee for low voltage fuses, and several of our colleagues are involved in the development of new standards from the field of fuses. So from the beginning, ETI were part of the procedure to make this standard. To prepare this standard, it takes maybe 2 years, but in the end of last year, in December 2021, there was presented completely new standard with the name Supplementary Requirements for Fuse Links for the Protection of Batteries and Battery Systems. There is a lot of information included here, but everything what is special to this application, it is described here in this part 7. But a lot of informations, a lot of requirements are also included in the basic IEC 269-1, which is named Low Voltage Fuses, Part 1, General Requirements. So, dimensions, some procedures for testing, and everything is described in IEC 269-1. In this part 7 are defined rated currents up to 5000 amps, and the manufacturer obligation is to include the technical specification information about derating characteristic if the permissible fuse link is exposed to high ambient temperatures. It is very usual that battery storage systems are installed in ambient temperatures higher than 40 degrees. So equipment which is installed there should have special characteristic or should be defined with information about derating. This is part of point 53 rated currents. You can see that in basic part, general characteristic of part 1, rated currents are up to 1400 amps. For battery systems, there are even higher rated currents up to 5000 amps. Power dissipation of the fuse links, there is written that manufacturer shall indicate the power dissipation at 50% of the rated current and 100% of the rated current, because usually battery fuse links are not loaded all the time with 100% of the rated current. And as I mentioned before, derating curve for increased ambient temperature has to be given in the manufacturer catalogs. There is some other points which are important. Those fuses should be designed up to 1500 volt DC. And what is important for the users, those fuses are designed in this way that they can be replaced by other fuse links having the same characteristic, same rated current, provided by their dimensions are identical. So presented is so-called G-BUT characteristic with fuse non-fusing current 1.13 nominal and fusing current 1.6 nominal current. Marking of fuse link from this range should be G-BUT or A-BUT. G-BUT is for general range, A-BUT is for limited range current, overloading current, and in additional combination of symbols of fuse and battery should be printed on the fuse. You can see here symbol for fuse and symbol for battery. It is also important that customers knows that something is different regarding other types of fuses. There is some examples from our product range. Cylindrical size 10 by 38, 14 by 51, and all sizes 1, size 3L up to 1500 volts and up to 630 amps. And of course, battery symbol or mark, which is designed by ETI, it is our, let's say, brand, which is also printed on the fuse links for battery protection. So G-BUT or A-BUT. ETI range is quite interesting. So as I mentioned, 10 by 38, 500 volts, 10 by 38, 800 volts, 14 by 51, 800 volts up to 36 amps. And then, of course, we can offer fuse holder EFH 10 DC or EFH 14 DC. From the range of NH, we started a few years ago with 80 volt generation up to 250 amps in size 000 and 00 and 1C also. Then, regarding requests from the market, we changed the voltage to 550 DC in sizes 1 to 3, up to 630 amps. Later on, again, a request from the market, higher voltage, 700 volt DC, up to 630 amps, again in sizes 1, 2, and 3. And last year, okay, there is 800 volts again last year, up to 400 amps in size 1 and 2. And what is the newest is sizes in long dimension, XL, 1XL, 2XL, and 3L, 1500 volts up to 630 amps. It is our range, and we can offer, of course, horizontal fuse switch disconnector as fuse bases for named HVA, and PK fuse bases from our regular production range. It was very short from my side. Any additional information can be arranged. Just contact me on email or by phone, no problem. Please contact me and we can discuss more about fuse links and for battery protection, and regarding some new requests from the market.